Hello students, this is the fourth session of this chapter. The topic is equations of motion by graphical methods. So students, basically there are three types of equations of motion. The equation for velocity and time relation, the equation for position and time relation, and the equation for position and velocity relation. So here I am going to show a video. This video will explain the derivation of equation of motions by graphical methods.
Welcome students. In today's session, we shall learn to write down the equations of motion by graphical method. We shall look into a uniformly accelerated object. The first equation of motion. Let us assume that a body is traveling with an initial velocity u and it reaches a final velocity v in time t. This is the graph representing the motion of the object. Acceleration is change in velocity by time taken. You can write it as A is equal to BD by AD, which is the slope of the graph, giving you uniform acceleration. A can be also written as AE by OC. AE can be rewritten as OE minus OA. Now we can substitute it with values of velocity. A is equal to OE is final velocity, which is u, minus OA is initial velocity, which is u. So the equation can be rewritten as A is equal to v minus u by t, which can be written as v minus u is equal to at. This is the first equation of motion. V is equal to u plus at. We shall move into the second equation of motion, taking the same graph. An object starting with an initial velocity u reaches a final velocity v within time t. You have already studied the area under the graph gives you the distance traveled by the object. The area of trapezium OABC gives you the distance traveled here. This can be rewritten as distance is equal to area of rectangle OADC plus area of triangle ABD. Now we will write down the formula for the area. Area of rectangle is length into breadth, whereas area of triangle is half into base into altitude. So total distance is written as area of rectangle, which is OA into OC plus area of triangle half into AD into BD. We can rewrite this as S is equal to OA is written as U, initial velocity, into OC is time taken plus half into AD is time again. AD is equal to OC. BD is rewritten as AT from equation V minus U is equal to AT. BD is same as AE, which is V minus U. BD is AE, which is V minus U, that is final velocity minus initial velocity. So BD can be rewritten as AT from V minus U. Now your equation stands as S is equal to ut plus half at square. This is the second equation of motion.